Okay, so now we're going to focus on graphing. We've talked a little bit about radicals. Specifically, we're going to talk about look at the square root function and the cube root function. Those are the radicals we're going to focus on in here. So before we do that, we need to recall domain and range. So what is domain and what is range? Remember? Remember, domain is the x values or the inputs, right? Because it doesn't always have to be x. It's whatever the input is to the function. And therefore, range then is the y values or the output. Great job. I knew you'd remember that. Okay, so to do this, we're actually going to be using our calculator today. You can also use Desmos. Desmos by far looks nicer than the calculator. However, I want to focus on the calculator just to help you out with other standardized tests where Desmos might not be an option. So let's first graph the square root function. So I'm going to go to my calculator, got my calculator, great. And then I'm going to go to y equals, awesome. Clear whatever's there, don't want that there. Now let's put in the square root, so square root of x. And now, again, I'm going to reset my window. So I know I've talked about this being a good practice. If I hit zoom 6, that will reset my window so I can see my graph in the standard window. Okay, so this is what the graph looks like. Technically, it's actually kind of a half of a or it is a half of a parabola turned on its side. Let's look at the table, though, also to get a couple of key points. So if I look at the table, I see it goes through 0, 0. I see it goes through 1, 1, and I also see it goes through 4, 2. So I'm going to use those points, and those are going to be really important for my graphing of functions. Is I want to definitely have a few key points that I know, so 0, 0, 1, 1, and 4, 2. And specifically, it's really important, the 0, 0, and the 1, 1. The 4, 2 is also helpful. If I kept going, I know it would go through 9, 3, and I know that because the square root of 9 is 3. And then it keeps going. My graph is not great here. It is showing it as becoming flat, or maybe even going down, but it does continue to go to the right forever, and it continues to go up forever. So with that said, then what is the domain? Well, the domain is 0 to infinity. Remember, domain is x values or inputs, and here we can specifically see this looking at the table, right? It's just saying error at -1. But at 0 has a value. Now, we could check, well, what about -0.5 or -0.1 or -0.01? Well, you're going to have to take my word for it. Those don't count. And actually, you don't have to take my word for it because you also understand that the square root of a negative gives you an imaginary number. And when we're talking about domain, we are always talking about real numbers. The range is also 0 to infinity. That is because the input of 0 gives us an output of 0. These will not always be the same for a square root function. Questions on that? Okay, all right. So let's look at the cube root function. So I'm going to go back to my calculator, and I'm going to clear that. And now remember, cube root is if I go to math, and then it's the fourth choice down here. So I'm going to hit 4, and we're going to do the cube root of x, and I don't have to, because I already just did this, but if I do zoom 6 to reset my window, I can see what the cube root graph looks like. Huh. Is that what you're expecting? I don't know. Let's look at the table and get a couple of key points. So -1, -1, 0, 0, and 1, 1. Those sound good. And then the graph kind of looks like this and like this. So here, the domain, notice it's going to the left and right forever. So that's going to be -infinity to infinity. And the range, although it is going to the left and right forever a lot quicker than it's going up and down, it is also going up and down forever. So that is also -infinity to infinity. So a hint, every single cube root graph is going to have a domain and range of -infinity to infinity or all real numbers. All right, so now let's look at C and D. So these are going to be transformations of these parent functions, and this is why it's really helpful to know the parent function. So first I would look at C and I would ask myself, okay, how is this transforming from the parent function? Well, hopefully we recall that the -3 is actually going to go to the right 3. So without doing any work, I know it's going to be that same exact graph, and this is why it's helpful to know some points. So 0, 0 is going to move to 3, 0, 1, 1 is going to move to 4, 1, and 4, 2 is going to move 3 to the right, so that's going to be at 7, 2, and now here's my graph. So that's why transformations can be super helpful. I could have also typed this into my calculator again, but if I know the transformations, it makes it much easier. Well, what is the domain? Well, in this case, I can see that the domain shifted because domain is x values, and that's inputs. So it shifted just along with the horizontal shift. So the domain is going to be 3 to infinity. But notice in this case, we didn't go up or down at all. So the range didn't change. My range is still 0 to infinity. Again, I could see this on my calculator if I wanted to, but the idea is hopefully, if we understand transformations, it makes graphing pretty easy, as long as we know the parent function. So I want you to try D on your own, pause the video, identify the transformations. You can use your calculator if you want, that's totally fine, but identify the transformations, the domain, the range, and then plot a sketch of the graph. Pause the video, do that, unpause when you're ready to discuss. All right, so here, hopefully you recognize the x plus 2 is going to go left 2, and the minus 4 is going to go down 4. So I just took these points at -1, -1, 0, 0, and 1, 1, and I moved them left 2 and down 4. And so that's these green dots that you can see here. Those are those points transformed, and then I just drew the shape. So what else did we say? Well, remember I said my hint was the domain and range of every cube root function is always going to be -infinity to infinity. So even though we did shift the graph, it did not change the domain and range. All right, so here I want you to try this on your own. We're going based off the parent function of square root of x. For each of these, I want you to describe the transformation, and I want you to match the equation to its corresponding graph and identify the domain and range for that as well. So go ahead and pause the video, identify the transformation, match the equation with the graph, and identify the domain and range. Unpause when you're ready to discuss. Okay, so graph or equation A actually matched with graph A, and this had a transformation of left 2. Just to save writing and space, for domain and range, I just labeled them D and R. So the domain is -2 to infinity, and I didn't emphasize before, but remember we use a bracket when we are including the number and a parenthesis when we are not, and the range is 0 to infinity. So we are including the -2 in the domain and the 0 in the range. For B, this matched with graph D. This shifted 2 to the right. So now the domain is +2 to infinity, again bracket on the 2, and the range is 0 to infinity, still bracket on the 0. Equation C, this matched with graph B. It went left 2 and down 2. So the domain, I miswrote, is -2 to infinity, and the range is also -2 to infinity. So I went left 2 and down 2. And then the last one, equation D. So this one, it went left 2, but we had a reflection over the x-axis. So that was the negative here, and I can see that reflection here. So the domain is -2 to infinity. However, the range, remember whenever we write domain or range in this interval notation, the lower number or thing has to be on the left. And so this is going to go down forever. So it's actually going to start at -infinity, and then the highest the graph gets to is a y-coordinate of 0. So this is -infinity to 0 with a bracket on the 0. Okay, so now I want you to try these two. Use your calculator or Desmos to help you out. But again, graph each one of them, describe the transformation, and identify the domain and range. Pause the video. Unpause when you're ready to check. All right, so A, we hopefully recognize this is going to be a vertical stretch by 4. So again, I'm using those points that I emphasized before to help me do that. So normally I go through 0, 0, multiplying that by 4 doesn't change it. But 1, 1, if I multiply the y coordinate by 4, that becomes 1, 4. And 4, 2, if I multiply the y coordinate by 4, that becomes 4, 8. So this is my vertical stretch. Domain and range are 0 to infinity. For g of x, this is a vertical stretch by 3 and a reflection over the x-axis. Domain and range are not going to change because it's still just a cube root function. But again, to show this, I took the points that are normally at -1, -1, 0, 0, and 1, 1. I reflected them over the x-axis, and I multiplied the y-coordinates by 3. So this is my vertical stretch. Again, you can use your calculator or Desmos to help you with that as well. Okay, so we've got one more to practice. So here, let the graph of g, which we don't have, be a vertical shrink by a factor of 1/6, followed by a translation of 3 units to the left of the graph of f of x. Write the rule for g. So I want you to write the equation for the g of x function that has a vertical shrink by 1/6 and is shifted 3 units to the left from the parent function f of x equals cube root of x. Pause the video, unpause when you're ready to check your answer. All right, so I got g of x equals 1/6 the cube root of x plus 3. This is my shift left. This is my vertical shrink by 1/6. Nice work. All right, so know the parent functions. Know the square root function, the cube root function, know what they look like, know their domain and their range, and then just apply transformations to them. You can always use your calculator. However, I think it's a lot easier, personally, if you just know what they kind of look like and some key points and apply those transformations. Nice work.